Okay, so we can review. We started talking about objects, and we had the introduction to two principles that are very important in object-oriented programming, and that is abstraction, how objects see each other, and how they can be set up to talk to each other. And then we talked about encapsulation, and in the simplest forms is just using variables and class functions in a class structure to create an object. And that's what we covered. Why do we do this? And it's to protect data, and only the object can modify its data directly. Other objects modify it implicitly after data validation is performed by the class in question. In this case, for example, the bank account class. We also covered examples. We started with this bank account class. We went ahead and created a simple public function, get balance, and that function, any users of the class can access it. And that same class had a private balance class member or variable, and only that the bank account class can access that data. And that's again to enforce encapsulation, protect the data integrity. In addition, we added a deposit and a withdraw class function. We did this to show how we can use encapsulation that allows other objects to modify data. If we go back to this abstraction example, well, I think it's this one, yeah. If we go into this abstraction example, we can see that another class can open or deposit or withdraw an account. However, it cannot see the internals, or how the class is saving or retrieving data. And if we think about it, those classes do not need to know how the bank account gets its data and how it saves its data. As long as a deposit goes through and the withdrawal goes through, in a real world scenario, obviously a receipt would be generated. But for these examples, they're bare bone classes to simply understand how we can create objects and give them actions. In this case, we are modeling a bank account, real world domain object, and we have a get balance, not open, deposit, and withdraw. But those are actions that other classes can perform on it. And then we also talked about initializing the private data. So if I go into Visual Studio Code and I bring up that header file for this class, the bank account header, this is what I'm talking about. We initialize private variables, in this case to 0, and we do that so that we can enforce a bank account where no one tells us what the balance is. We just say, okay, it's 0. And then we use what we know is the default constructor. And also, since we are talking about constructors, it is important to understand that if we do not provide any constructors, if this code was not here, then C++ generates a constructor behind the scenes, right? What is a constructor? This is a constructor. It's a special function named exactly as the class with 0 or more parameters. The default constructor C++ creates is something like this. It simply doesn't do anything. However, it allows developers to create instances of a class. Why do we have to create instances? Because when we create this code here, we are simply creating a blueprint for a data type that we create, user-defined type. And it's important to understand that. Also, if we have one constructor with at least one parameter, then C++ does not generate the default constructor behind the scenes. And that is because C++ doesn't know if we need it or not. In this case, we opt to use it, and then we use the keyword default just to indicate that this is behaving like the default constructor. Okay? And briefly here, I'll summarize. So if we create, for example, if this is the code, only this right here, then bank account, we create a bank account instance, we go back to the header, the compiler will use this constructor. However, our balance will be 0 because we initialized balance to 0. If we decide to send in a value, when this statement executes, C++ will use this constructor. And just to reiterate the point, in every class, C++ reads the class variables first. That way all constructors and class functions know that the balance variable exists. So in this case, for an instance, balance is 0. However, when this statement is called, B is 90. And then we say balance, overwrite the value with 90. So now the value for balance is not 0. Instead, it's 90 because that's what we initialized it to. Okay, so very important concept here that we talked about. Okay. What will we talk about this week? We will take a deep dive into how functions are mapped in memory. That will give us a good understanding of what happens when classes are in memory and we decide to create copies of classes and what have you. And this will only be for static memory. We will not be dealing with any dynamic memory. So if we come and look at this, make sure you read chapter 11. We will probably be able to cover most of this week, so read chapter 11. If you've not read chapter 7, then go ahead and read chapter 7. Okay, and thank you.